Hello everybody and welcome to the first video of this week for our online class. We're going to be going over solving algebraic equations. So I'm going to go over some basic operations and some two-step algebraic equations which should be a review for you, and then we'll go on to some harder things moving on in the next videos to formula, manipulation, and substitution. Okay, so a basic operation, there's a couple ways you can think about solving algebraic equations. So the first way is to sort of think and look at them logically. So let's say I was to cover up this variable here. It becomes a lot easier for most students to see what we're trying to do. So those variables, those letters in the algebraic equations are just sort of question marks. They're just asking us what number should go there when we're solving these equations. So if I cover it up and put a little blop over my page there, I need to figure out what number should go there. And most people say, well, I know that I'm subtracting 3, so I need to add 3 to 12 in order to figure out that 15 is going to be the number there. And you would be right. It would have to be x equals 15. Okay. For the next one, it's the same idea. So if I was to cover up the variable there, you could think, what plus 3 is 12? Well, 9 plus 3 is 12. So our variable must be 9. Or you could think of it as, 12 minus 3 is 9. Okay? And the same thing goes for our next equation there. If I was to put a cover up over that, something divided by 3 is 12. So you're thinking to yourself, well, I know 12 times 3 is 36, so our variable there must be 36. So x, in this case, is 36. 36 divided by 3 is 12. And finally, if I was to put a little blurb there, when you have a number and a letter that are squished together like that, they're being multiplied together. I have 3 times something. So 3 times what is 12? Well, that would be 4. So in this case, our variable is 4. Or you could think of it as 12 divided by 3 is 4. So you'll notice we're always doing the opposite of what is the operation that's in front of the number, or the number we're trying to get rid of in this sense. Okay, so let's move on to some two-step algebraic equations. So we're going to have to do 2 things. Okay. So our goal when solving these is to get the variable, which in this case is t. We want it to be on its own on one side of the equation, and all the numbers to be on the other side. So here, there's the 2 things that are happening to my variable is it's being subtracted, 7 is being subtracted, and it's being multiplied by 2. So you need to be thinking about what is the easiest thing or the easiest operation to get rid of here. And in this case, I want to get rid of this minus 7 first, because it is the easiest to get away from the t. The 2 is attached to the t, and if I was to divide by 2 first, I would also have to divide the 7 by 2. Okay? Because whatever I do to this side, I have to do to everything on that side, not just the t itself. Okay? So I'm going to take that 7 and I want to get rid of it. And to get rid of it, I'm going to add 7. But we know that we cannot just simply add 7 to one side. That's going to change our equation. So I'm going to have to add 7 to this side as well. And that leaves me with 2t equals 16. And we're back to our first step we did before. You could say 2 times what is 16, or you can divide both sides by 2, and that leaves me that t in this case is 8. Okay. Or if you want to think of it how we did before, when I was doing the basic ones, you could say, well, if I was to cover this up, then something minus 7 is 9. Well, 16 minus 7 is 9. Okay. So I know that 2t must be 16. 2 times something is 16. 2 times 8 is 16. So depending on how you want to think about it, you're welcome to look at it either way. Okay, let's do 2 more examples just to make sure that we understand the 2-step problems we have going on here. Okay, so in this one we have a minus 10. The variable is being subtracted and multiplied as well. So the 10 is the easiest one to get rid of first, because the 4 would have to multiply or divide the 10 and the 2, not just the 4. So I'm going to add 10 to both sides because I want to get rid of minus 10. Okay, that gives me 4x equals 12. And now 4 times what is 12? Or 12 divided by 4 is what? And we know that is 3. If you prefer to think of it the way the second way, you would say, well, something minus 10 is 2. So 12 minus 10 is 2. So 4x must be 12. Whatever's under here must be equal to 12. And then it's the same process from there. 4 times what is 12, and that is 3. Okay, last one. Here I have a 7 and a times 5, times a negative 5, actually. So in this case, the 7 is the easiest to get rid of first. So I want to subtract 7 from each side, because remember, that 7 has a plus in front of it. It's being added. So I'm going to subtract 7 from both sides. And that gives me negative 5z. Don't forget the negative in front of that. Equals negative 25. So that means z is going to be 5, because 5 times negative 5 gets you negative 25. If you prefer to think of it the other way, if I cover this up, 7 minus what gets you to negative 18. And that is going to mean that our negative 5z is going to be negative 25. So z is 5. Okay. Okay, it gets a bit trickier when you have variables on both sides of the equation. We want to essentially get all of the x's to one side and all the letters without x to the other side. But before I do that, I notice that there is some brackets, and it would make it so much easier if I could simplify that side so that there wasn't any brackets. So that's the very first thing I'm going to do before I even try to solve. Now, that bracket is being multiplied by a negative 1 or a negative. So that 6x is going to become negative 6x, and that minus 8 is going to become plus 8, because this negative is going to affect both the 6 and the 8, not just the 6. Don't forget that. Okay. So now I can simplify that further because I see that I have a 3x and a 6x on the same side. So the first thing I'm going to do is simplify that. So I get x minus 7 plus negative 3x plus 8. Okay, I'm going to bring this negative 3x, I'm going to bring it over to the other side, or get rid of it on this side to bring it to the other side. So to do that, I'm going to add 3x to each side. And if I simplify that, that gives me 4x minus 7 equals 8. And now it's back to the same way we did it before. So I want to get this minus 7 away from the 4x. So I'm going to add 7 to both sides. So that leaves me with 4x on this side and 15 on this side. So x is going to be 15 over 4. And I'm going to leave my answer in a fraction because it's much more accurate than trying to put it into a decimal and round. So I'm going to leave it into a fraction there. Okay, let's try another one. So this one doesn't have any brackets, but I still want to get all the letters to one side and the numbers to the other. So I'm going to bring this negative 3L, I want to bring it to the other side. So I'm going to add 3L to each side. So I get 6 plus 4L minus 3L, or sorry, plus 3L, 5 minus 3L plus 3L. Again, I'm adding 3L because I have a minus 3L there, and we always do the opposite to get rid of it. So this side becomes 6 plus 7L, and this side just becomes 5. So now I'm going to bring the 6. I want to get rid of this 6 here, and it's a plus, so that means I'm going to subtract. So that means just 7L on this side, negative 1 on this side. So I'm going to divide by 7, and I get minus 1 over 7. Okay. Okay, again, this one has some brackets. So I want to simplify, get rid of the brackets first before I try to do anything else. So in this case, the bracket is being multiplied by a negative 6. So negative 6 times 2 is negative 12. Negative 6 times negative 3 is positive 18. And the t tags along there. Now I see that I have two numbers without variables, so I can simplify that. Okay, so that gets me to negative 9 plus 18t equals t minus 5. Okay, I am going to bring this t over. So to get rid of a plus t, you have to subtract t. So I'm going to subtract t from both sides. And that leaves me with negative 9 plus 17t and negative 5. Don't forget that negative there. Now I'm going to bring this 9 over to the other side, or I want to get rid of that plus 9 so that the t is by itself. So I'm going to add 9 to both sides. And that gives me 17t equals 4. So t is going to be 4 over 17. And again, I'm going to leave it as a fraction because it's more accurate than if I try to leave it and round as a decimal. Okay. Now, for any of these ones, if you want to check your answer, if you get an answer like this, when I first got an answer like this, I thought, I'm not sure if that's right. So to check your answer, you just take that 4 over 17 and you're going to substitute it in for t and solve and see if both sides equal out to give you the same answer. And we're going to work on substitution in our third video. So you can use that as a way to just check your answer if you're not sure. Okay, this one looks different, but it really has the same principles. This x is being divided by an 8. So to get rid of a divide by 8, I'm going to multiply by 8. Okay, so I end up with 8, and I'm going to put a little dot as our times because I don't want the times and the x to get confused. So I'm timesing both sides by 8, and that leaves me with x on this side, and 3 times 8 is 24 over 4, or I can simplify that as 6. And we can also look at this logically and notice that 4 is half of 8, so 3 will be half of 6 because they're proportional when you have an equal sign like that. But just so I would follow this other procedure for the most part because it's not always going to be that simple and that easy to solve. Okay. Okay, and our final one, it's got a bit of fractions on both sides as well. So we're going to treat it the exact same as we did before. We want all the x's on one side and the numbers on the other. So I'm first going to get this 3x over to the other side, and to do that I have to get rid of it on this side. It's right now a positive 3x, so I'm going to subtract it. So I get 2x over 5 plus 4 minus 3x is 3x minus 35 minus 3x. Okay, and that leaves me with 2x over 5 plus 4 minus 3x here, and minus 35 here. Now I want to get this 4, get rid of that 4, so it's a plus 4, so I'm going to subtract it. So that gives me 2x over 5 minus 3x equals negative 39. Now this looks a little bit tricky because how do you subtract a 3x when the other one has a 5 on the bottom? So the best way is to make this 3 a fraction over 5. Right now, remember, it's technically a fraction over 1. So I'm going to have to multiply the top and the bottom by 5 in order to make it a fraction over 5. So I end up with 2x minus 15x over 5. So my 3x over 1 is the same as 15x over 5. I've just multiplied both the top and the bottom by 5. Okay? So 2x minus 15x is going to be minus 13x over 5 plus minus 39. So now I'm going to get rid of this divided by 5. And to get rid of divide by 5, you're going to multiply by 5. So that is going to be 5 times negative 13x over 5, and 39 times 5. And that gets me minus 13x is negative 195. So now I'm going to divide both sides by 13 in order to get rid of the multiply 13 there. By negative 13, I should say. And I end up with x is 15. Okay, so I will have this as a PDF document that you can follow along with as well, so that you can see everything we've done and worked through. So keep tuned for the next 2 videos.